Okay, to continue, January 2013. We'll start with number 33. The number of bacteria is modeled by this formula. Now, watch what they do. N is the number present after, so at the end, T hours. T is your time. Using this model, and circle this because you need to come back to this, find the number of hours you are looking for T that it takes for N to reach this. This is what we're plugging in. So substitute in. This is a natural log problem. Get E by itself if possible, and we can divide by 50. The only thing that will bring down an exponent is a power log rule. So you need to apply the logs to both sides. But because this is an E, a natural log, we have to ln both sides. This comes down. If you remember your properties, ln E cancels out to 1. Then divide both sides by 3. And go back and look. You needed to round to the nearest hundredths. That's the time in hours that it will take. And make sure you do your rounding right, or you're going to lose a full point on rounding. Number 34 is an absolute value inequality. Now remember with your absolute values, a grador says oars on a boat like this. Absolute value also says make sure your absolute value is isolated. If there were any other terms by your absolute value, get them to the other side. Isolate your absolute value, which this is. Then you're going to do a positive root and a negative root. There's your oars that go out like this. So bring it out, keep it to where it is. On this side, bring it out again. When you use the negative 7, when you take a negative with an inequality, you switch the signs. These also have to match these arrows. See them? They have to match the arrows. Then solve for each one. Just solve for each one. When you divide by a negative, remember to switch your sign. And do the same for this one. Subtract 3 from each side. When you divide by a negative, remember to switch the sign. Now, make sure you put the or in here. So you've got x such that x is less than or equal to negative 2, or x is greater than or equal to 5. If they want interval notation, use your number line. Here's your negative 2, it goes this way. Here's your 5, it goes this way. Negative infinity to negative 2, hard bracket there, or 5 to infinity. This one kind of surprised me that they stuck this in here. But remember, when you have a circle, 180 degrees is half of your circle of 360. Your whole circle is 2 pi. So therefore, 180 is pi. This is key. 180 degrees is pi. So therefore, 180 over pi is 1, and pi over 180 is 1. So if you want to go radians to degrees, so let's take a different angle. 5 pi over 4 to degrees. We want the pi on the bottom. Now, just because it said 3, we have to still use the same routine. 3 times 180 over pi. And they want this to the nearest minute. So you're going to multiply this out. Multiply 3 times 180 divided by pi. You get approximately this. Then go degrees, minutes, and seconds. And round it to your nearest degree. Make sure you show work, because without showing the work, you're not going to get any credit. Now our problems start to get a little bit harder. Here's a log problem. Easiest way to do logs is to say log equals exponent. The base of your log is this thing down here. So it's the base of my log. There's my exponent right here. 2 equals this mess. Now, that set is the setup. Log equals exponent. Take the base of your log, raise it to the exponent, equals the 17x minus 4. Remember to FOIL this out. Don't skip any steps. Show them what you do. Collect your like terms. Subtract 17x, add 4, set it equal to 0. So you're going to get x squared minus 9x. Once you have a quadratic, you know you're factoring. And factor. So x is equal to 4 and x is equal to negative 5. Remember to check both of these answers, because you could have something that causes you to take the log of a negative or a 0, and that's not going to work. So make sure that you check both answers. In number 37, they're asking for an exponential regression. An exponential regression works just like your linear regression. Round your numbers to the thousands. Be careful. And make sure you show work. This is your L1, this is your L2. Make sure you state that. This is the first part, this is the second part. So make sure you do both. So you're going to put this in your calculator and you're going to tell them, stat calc, you went to exponential regression, L1, L2, Y1. Put this in L1, L2, go here, make sure you put your Y1, and I like to go to my Y equal and round those as well. And you should come out with your equation. Rounded to the thousands. The thousands is 3 decimal. This is the first part. Make sure you label everything. Now, the second part of this says, assuming this trend continues, you're using this equation, find to the nearest 10 the number of bacteria after 7 hours. Okay, hours is your x value. There's your x value. You want to substitute that 7 in. Show the substitution first. Use the equation you came up with and show the substitution. Then put it in your calculator. If you changed it in your Y1 on your calculator, you can certainly go to your table and pull it out. And make sure you round to the tens. If you round incorrectly, you lose a whole point in rounding. Number 38, make sure you read this correctly. There's 2 fire tracking stations, A and B, and they are 100 miles apart. And at F is a fire. They are spotted from both of the fire tracking stations, and they give you the degrees on your graph. The first thing you should always do when you have a graph is to fill in any angle that you can. So knowing that this is a right angle, so is this one. So use the fact 90 minus 47 and find this angle to be 43 degrees. Then use this fact. See this 15 in here? This is 90 plus 15 in here. Using these two angles of 45 and a 105, you should be able to subtract them from 180. So this is 180 minus 148, and this will give you 32. That's this angle up here. Now, it is asking you to find both station A and station B, the distance into the 10th of a mile from A to B. So I'm going to call this one B and call this one A. Now, luckily, they're both law of sines. So you've got B here, and the one that's given is this one right here. So your law of sines says 100 over the sine of 32, this one you know, is B over the sine, and be careful, that's not a 90, that's a 105. Cross multiply and find your B to the nearest 10th of a mile. Then remember to go back and do the same for A. A, you're going to use the same one that you had, the 100 and the 32, and then this way. So we've got 100 over the sine of 32, and we'll put our A information in. This was fairly nice because you were only looking for a side, not an angle. Cross multiply and round this also to the nearest tenths of a mile. The key is make sure you understand your diagram. And our last problem was a nice problem. It was a radical. Now, to undo a radical, you know you could square it and get rid of your radical. But, just like an absolute value, you have to isolate the radical. So this has to be by itself. So subtract 11x. Now, when you want to undo your radical, you square, and you square this side as well. This has to be FOILed out. There is no shortcut to doing that. So you have to FOIL that out. When you square this side, it just pops right out. So when you FOIL this out, collect your groups, it should look like this, 24. Okay, because you have a quadratic, get everything to one side. Subtract the x squared, the x, and add the 1. Now notice, you have a common factor. Your common factor, your greatest common factor right now is 5. So divide, because this is an equation, divide by 5. And factor this. Use your A times C and get your factors. 3 is a prime, 2 is a prime. There's not too many tries you're going to have to take to get that to work. Set them equal to 0. And remember, because we manipulated this radical, you need to check both answers. Bring them back to the original problem and check. This one will fail. We have to reject this one. And so therefore, your answer is just this. So this completes the January 2013.